So, second last presentation of the day in the conference, I guess. We have Nicole Harper here from Pacific Flow Control. Nicole is a civil technologist with almost 15 years experience in the construction industry, from heavy structural civil, building hydro generation facilities, coming full circle to water distribution. A perpetual student, she is just finishing up a bachelor's degree at BCIT in technology management and looking forward to the next challenge. So Nicole's here to talk about PVC safety, what can and can't be hot tapped.
Thank you very much. So good afternoon, everyone. As she said, my name is Nicole Harper, and first, thank you for being here today. My apologies, I just got back from holidays, so we will be struggling through this presentation, my very first professional presentation of this size together, so lucky you. I've been with Pacific Flow for just over 6 months, and as noted, my first 15 years, heavy civil construction. So I ended up here because it was time to learn something new and to exercise the gray matter, and here we are. So as you can see, the presentation is going to be about PVC safety, and I would say multiple times per week, probably 4 or 5, 10 times, we get asked questions about what can and cannot be tapped in regards to PVC. So the answer is always, it depends. I need more information. So of course, we all know how accurate record drawings are, and we do the best we can with what we have. And when we finally get into the ground, we find out it's AC anyways, so it doesn't matter. So I will be going over the Unibel guidelines here and attempt to make it a little bit entertaining, as we all know standards and specifications are just great literature for when you can't fall asleep. And I also know, I'll also show you a couple case studies of taps that we've done and some real examples that we've done, so super exciting. And to kick us off, I'll just show you guys a video here real quick, and then we'll roll into the safety aspect of things. Oh no.
What's wrong with that? He's holding an electric drill. That's intelligent. Something I think that was it.
It looks like we're having a little bit of a technical difficulty here, so maybe if we can get it rolling by the end of the presentation, it comes up again. So that's fine if it's not working here. So put your hand up if you've ever had PVC light go on you. No one, really? Wow. You guys are, you've seen it. Okay. So most people know that PVC is the most dangerous pipe to tap because of the catastrophic failures. And so it just explodes, splits, PVC shrapnel everywhere, and for that reason, that's why it's most dangerous. A common reason older PVC splits is because of poor construction practices. So thanks to the, I guess, the flexibility or the presumed flexibility of the pipe itself, this would happen more frequently, let's say in Alberta, since we're not in Alberta, and nothing like that ever happens here, of course. So it's, let's say it's Saturday afternoon, 25 years ago, and Bobby the backhoe is digging away, and, oh, he's got the video here now, okay. So yeah, as you can see, pretty catastrophic failure, and then from there it's just chaos, right? So Bobby the backhoe is digging away in his trench, and he comes across a Volkswagen-sized Beetle boulder, or even a Volkswagen itself, and they don't have equipment big enough to get it out of their trench or move it out of the way. Saturday afternoon, and of course, so Fred the foreman says, look, EMCO's closed, I can't get any bends. And you know what, it's almost lunchtime, we have to get this done. I'm gonna take Ivan the inspector out for lunch for beers and steaks, and you just get it in and backfill it. And so Peter pipe layer flexes the pipe around the boulder, Bobby backhoe, and he backfills, and there's tons of tension on the pipe. Out of sight, out of mind though, right? So 20 years later, we come along, and sometimes all you have to do is touch this pipe little, and it'll split, bell the spigot, and you either have water or sewage flowing everywhere. You know, Burrard Inlet right here, all these beautiful hotels. That's just bad news. So it's pretty rare, about 1 in 1,000 taps. Luckily, Pacific Flow Control does over 1,000 taps per year, so we like to think we know what we're doing, but pipe is typically more correctly installed these days. I know inspectors have a hell of a job out there, and it's really underappreciated for what they have to do and the conversations they need to have on a daily basis. So, we are one ahead here. So to kick us off with the a little bit less exciting, but the most important, some general safety guidelines, and they would be applicable to all hot taps. So the measures that we need to have in place for excavations, we all have heard stories or have encountered WCB hammering down or giving out fines for confined spaces and excavations not meeting proper requirements, not having engineering sign off, not having been reviewed by WorkSafe. So once you have WCB's attention, it's really hard to divert somewhere else until somebody else makes a bigger mistake, and God forbid anybody gets hurt. So always have a way out of an excavation, whether that's the ladder, a sloped or stepped excavation, and make sure you know where your way out is and where the proper PPE. So a second worker is really important. A lot of the times we get to site and the guys leave. They're really used to us having successful taps and everything going well. But one time in the interior, the guy had the pipe burst and had someone who's scrambling to get out of the excavation, and at that point you're not thinking, you're just wanting to get out of there. So he hit his head on the shoring, and had a second worker not been there to help him out, it could have been pretty bad for him. So a protective blanket is useful just for keeping shrapnel from hitting you in the face, help you save your eyeballs, but you should be wearing proper eye protection anyways when you're tapping PVC, tapping anything. Pressure's pressure, so it's just gonna, save you some potential injury. And when we send quotes out that are all thoroughly read and understood, we ask that valves are throttled down. And that doesn't mean off, it just means that we want you guys to locate these valve box, pops the lids, clean them out, make sure that you can operate these valves, that they're not seized, so in the event something happens, it's a quick couple turns and we're not scrambling at the end of the day. In the event something happens. So the main thing, just knowing you can get that box open in the first place. And on that note, pressure is pressure, whether it's air or water. Just know where those valves are. So the volume coming out will be way less if you've operated and exercised that valve. So air should always be removed from the line. Air acts as a spring, whereas water acts like a wall, and 100 psi is the same whether it is water or air. So, but they act very differently when they explode. So, because air is compressible, when it releases, it decompresses and acts like a bomb, whereas water, hydraulic fluid will just spill out everywhere, unlike that video, but either way. So if you blow a cap off, it's going to blow 200 feet in the air with air, and if you blow a cap off with water, it's only going to go about 20 yards. So the real difference is between breaking bones and dying in this case. So the tapping machines that we use for the smaller taps, we use T101s, and they're fully threaded on and off, so they don't have a cheater like a cheater bar that allows you to shortcut the option and run that cutter all the way to the pipe in a lot quicker manner. And so the problem is, if you don't purge the air off and you're unthreading, your last thread is going to pop off with that quick release, decompress the air, and launch it backwards into your kneecap or whatever's sitting there to get knocked off. Now, water can still do that, but it won't be as forceful. So pressure testing, Pacific Flow Control, we always recommend that you pressure test your system. It's totally up to you, but Murphy's Law, if you can't have it leaking, it will be leaking. We are there because you can't shut down your system, and so we will always pressure test everything. Downtown Vancouver, 100% pressure test every single time. If you're in a small little cul-de-sac, small residential line, 3 or 4 houses, not really a big impact. You can deal with a few people yelling at you for a couple hours. Then, you can do a quick risk analysis in your head and determine whether or not you want to shut it down. But we would always recommend doing a pressure test ahead of time. So when we do our tests, we run pretty high. Air is 89 times more viscous than water. So if you put 30 PSI of air into a service saddle, that's going to be enough. You could do it with a bike pump even. And we change between air and water depending on the nozzle size. So at a 12-inch nozzle size, we're going to go switch to air, water because it takes forever to fill that cavity with with air. And again, if it holds, we'll hold it as long as we need to, and we make sure it won't leak. If it leaks, we take it apart, redo it, run the test again, and until we get adequate pressure holding. So another thing to keep in mind is that you really don't need insanely high pressures to do your tests with. Just follow the guidelines for the pipe and the main pressure. And we find some folks will ask for really high pressure tests and they don't know why they're asking. But bigger isn't always better, and it can be really dangerous. If you do a quick YouTube search, you can find hydrostatic pressure tests like ripping metal pipes apart. So just keep that in mind. So two different examples of hot tap sizes, and you can see the kind of pressure that can result on a 2-inch line, 314 pounds of pressure. It's going to break some bones. It's going to hurt. Someone was recently doing a hydrant service, and they were going to pull the main valve off. So they jump on the hydrant, they crack the main valve, and then they get a phone call. So he tightens back his main valve up. He heads to his truck, takes a call, and what he didn't realize was that there was enough blow by to pressurize the system with air and water. So 20 minutes later, he comes back, hops on the hydrant again, cracks the main valve again, and it's corroded, it's crappy, what have you. So at this point, he doesn't know it's pressurized up again. The main valve explodes up, cracks his jaw, and he's passed out. No one finds him for hours. A neighbor found him in the grass, passed out. So, just keep your pressures in mind. It can happen to anybody. And another thing that commonly happens with residentials, plumbers will pressure test, and they will leave about 115 PSI in the line. You can flush your toilet a couple times, you can clean your boots, you can do a little bit with that water. So, and they'll do that while they're waiting for their tie-ins to be completed. And what happens is that the muni shows up, you guys show up, and you'll have a senior and a junior because everyone knows there's not enough guys, and he's green as grass, and you say to him, I'm going to go get this ready, bevel the ends, get these row bars ready, you go and pull that cap. So the problem here is that it's a 1-bolt cap. They're great, but they are dangerous. So the apprentice takes his electric drill, undoes the cap, and he's standing right behind it, undoes that single bolt drill, and the cap blows off, hits him in the chest, hits him in the face, he's dead. So really pay attention to your pressures and make sure you're bleeding it off your system, and if you're doing any work on your infrastructure, just bleed off your system. Okay, so recently we encountered some bionics pipe, and so that led to further questions because apparently you can, with bionics pipe, with IPEX's blessing, you can have scenarios like this where you can have no spacing at all between any of your saddles. And same thing, no spacing from the back of the bell, from the spigot, from any other restraining appurtenance on the pipe. So there's only one municipality that we know of that has this kind of pipe, C909, in their system currently, and there's no published literature on it. They are promoting it really heavily in the east, out in Ontario, but there's nothing formal, I would say, until actually the conversation we had. We do have an email saying that it's fine, so we will take that. And I think we got it like 2 days before, like last week, before this presentation. So otherwise, we would be following Unibel guidelines for all spacing and offsets. But this should be noted that it is limited to saddle taps. And they do not endorse direct tapping in any way, shape, or form. So as you can see here again, no space between these saddles, and he's just tapping away. From what we understand, everything worked out great. So we've also requested a schematic like this from IPEX for this C909 pipe, but as everyone in construction, they are slammed. So otherwise, offsets are typically 2 times the OD, except for in places like Alberta on PVC C900, they require 1 meter spacing, and that's not from the center of the hole, that's from their fittings, everything. So it's going to be greater than 1 meter at the end of the day. And now direct tapping and saddle tapping, the difference is obvious to me, but direct tap is, you have nothing on the pipe. You're just basically drilling into it the way it is. And saddle tapping on the nose, as it sounds, you have a saddle on the pipe. The Unibel guidelines are very clear on what can and cannot be tapped, so always follow that. Now, just to break up some of the rules for a second, we have a case study of a C900, a C905 hot tap that we did in Kelowna a little while ago. I think it was last year. Anyways, so this is white pipe, and as soon as you see white pipe, oh, where'd it go? There it is. As soon as you see white pipe, alarm bell should be going off right there. Can we even hot tap this pipe? If you're lucky, you have writing on that pipe like this one does. But first things first, you want to find out the DR, or the dimension ratio. So this pipe is DR41 C905 pipe. We can if it's AWWA grade pipe, C900, C905, oh, what's going on there? C909, no matter what it is, DR41, DR11, we can hot tap it. But you just want to make sure that you have the proper contingencies in place, you have extra pipe, you have some row bar couplers just hanging out just in case. Anything outside of a DR26 really is a non-standard tap for us, and so you need to know that the liability is on the owner at that point. So series grade pipe, which is an ASTM grade pipe, or a schedule like a Sched 40, Sched 80, we can tap it, we can saddle tap it, but we will never, ever, ever direct tap a series grade pipe. So how did we know that this pipe was an AWWA grade pipe? Well, as we saw in the first slide about it, it had writing on the side. So the writing on the side told us exactly what it was. We were really lucky. And we could just get ordering the sleeve, and it speeds up the timeline and get the best manufactured recommended sleeve for this pipe. If there's no writing, again, alarm bells should really be going off now. The pipe is probably so crappy that they didn't even bother stamping it. So it's something probably like glued irrigation pipe or something. And so the first thing, again, you want to get an OD, and not with a shoestring. You want to get a proper OD tape on that pipe. If it's ductile iron sized pipe, then it's no problem. That is typically AWWA sized pipe. They're the only people who would make AWWA sized pipe anyway. And what we're seeing more and more of in the interior is that these municipalities are taking over these irrigation districts. And so back in the day, there was some very thrifty farmers putting in whatever they could get. Often it was series grade pipe. And so these farmlands are now being turned into 1 acre beautiful lots owned by the municipalities, and you won't find writing on those pipes. So whatever you do, just be careful, take the proper necessary precautions, and better yet, just replace it completely if budget allows. Make the developer replace it. And so steel grade, again, ASTM pipe. To get the DR, you can do that by excavating back to a bell end and taking a measurement of that bell, how thick the pipe wall is, and then back calculating it. So you pull the OD, and from that, that's how you can get that DR rating. So quite clearly, we tapped this pipe. This is the finished product. It was a no valve hot tap, and so they wanted to install a plug valve, and to do that we use our line stopping machines and a line stop fitting to be able to stop flow from the sewer pipe to allow the valve to be installed after we've removed our hot tapping equipment. And oh, where did it go there? Okay, so this is the calculation I was referring to previously. So multiply the thickness of the OD of the pipe, and that will give you the DR. So remember, the higher the DR number, the thinner the wall pipe you're going to have. And in that case, bigger is not always better. And anything greater than 26, DR26 again, is non-standard for us. So in any case, when tapping PVC, you should always have your contingencies in place. Know where your isolation valves are. Know that you can operate those valves. Have some couplers and pipe on hand. So coupons are always a sure tell of what was being tapped or how the pipe was being tapped. So the two top ones are obviously great coupons. They're in great condition, nice, sharp, clean cutters. Everything's even on it. The bottom one, I know it says melted plastic, but the cutter is out of round. So just throw it away. It's garbage. And you typically won't be running anything fast enough to melt the plastic. If you are, it's only a matter of time before you have something happen. So on the top, the crowning, you cannot manually feed a hot tapping machine fast enough for the coupon to melt and do this. If you are, you're using a drill, and you look like our buddy in that video, and you should not be using a drill. So in this case, if you are, you need to look up the max RPM, and it's something like 12 RPM, and it'd be really hard to run it at that. But there's a new Milwaukee drill that you can control the RPMs from your phone, so you could do it that way. But in any case, always follow Unibel guidelines, Unibel recommendations. And like I said before, the coupon will always be the telltale sign of how it was tapped. So if you blow it up and you find the coupon, it looks like this, you could be in some trouble. So the punch through on the bottom, one of two things, the cutter could be forced through the pipe at the end, or the cutter's dull. So if you're seeing taps like this, then really slow down, and what you should just do right as you're getting to the end, just slow down and let it flow through itself. And if you're still seeing that, then it's likely that your cutter is dull and you should just sharpen it. I think you can get 5, 6, 7 taps before you can need to sharpen them again. So direct tapping, as I said before, I'm not going to get into it because we don't do it, and typically the Unibel Bible says you shouldn't be doing it, but they're very specific on the application. So whatever you do, just follow Unibel guidelines. Saddle tapping, so suppliers are always going to want to supply sleeves that are going to hit the greatest range. And so they'll want a sleeve that hits C900, ductile iron, AC, oversized cast, and regular cast. So obviously there's going to be problems with that, and unfortunately you're not going to get good gasket compression or fit. So for saddles, we want to make sure that the correct saddle is used, with the correct straps are being used, and you want to have a saddle that fits the pipe properly. So you don't want to have any gaps like it's showing here on the side, and you don't want to try and round the pipe or round the saddle to the pipe, because then you're putting a lot of external forces on that pipe too. So it could result in a failure. So again, as Unibel says, it should be designed and rated for the PVC pipe that it's going on, and to provide support to the entire circumference of that pipe. Saddles should not have anything on them that can cut or bite into the pipe when a saddle is tightened, and that is properly rated for the line, of course. And you want to make sure that you have IP threaded saddle, you have an IP threaded Corp stop, or CC threaded, right? You always want to have compatible accessories. What not to tap with, so you'll see a shell cutter in just a second, but you shouldn't be using a drill, a spade, wood bits, hole saws, ductile cutters, anything. On PVC, it can potentially cause a pipe to fail. If you use the appropriate cutters, you'll get good, clean cuts, you'll retain your coupons, and you won't clog your system with tons of shavings. So if you have a thicker DR, DR14, DR11, you're likely going to need a deeper cutter. So the two there is what you should be tapping with. That middle cutter that you see there, that one is something a lot of contractors will use, and they will cut absolutely everything with it. Don't use that cutter, just use a PVC cutter. The bottom two, those are typical PVC cutters, and that's, as you can see, you get good clean cuts out of them. So with taps with a nozzle size up to 2 inches, it can be done with a saddle, and you're going to need to move up to a sleeve if it's beyond that. Both live and dry taps can be done with saddles. And as you can see here, 12-inch mains and under, you need to have spacing that is no closer than 2 feet to the back of the bell, 2 feet to the spigot, or any restraining hardware. On taps over 14, the tap from the center should be no closer than 36 inches to the back of the bell. And of course, you want 18-inch spacing between taps. So things to consider for saddle taps: throttle down your main, install the saddle as per the manufacturer's recommendations, ensuring that there's no pipe deformation. Of course, if you have any kind of written literature saying that supports any kind of deformation in the pipe that it won't affect the structural integrity, then you're fine, but I would always suggest having something in writing to back it up. PVC is a really smooth cut, so just make sure the proper feed rate is maintained and don't overfeed or force your cutters, and just make sure that you're cutting all the way through the pipe but not cutting through the back end, and I wouldn't mention it unless it's happened. So we mark our machines with reference points, and the guys know how many counts or how many rotations they know to make sure that they're cutting through the pipe fully. And some of the guys have been doing it long enough that they can just by feel, they know when they've cut through the PVC. But it's always best just to know your numbers for your machine. So standard tapping saddles, ignore the two on the bottom right here. Depending on where you are, some places in the entire interior and all of I think Lower Calgary, Southern Alberta, they require fully stainless steel saddles on their PVC, or sleeves rather. BC is a mix of everything, and so bronze, brass, ductile, it's very common with stainless steel straps. Threaded sleeves for larger OD and higher pressure pipes. We keep these on the shelf in all sizes, so we always have something available. Getting into sleeve tapping now, it isn't that much different from saddle taps. So again, most manufacturers, they will want to sell a sleeve with the greatest range, and the problem with that is that it's going to be oversized in a lot of cases. So the first 50 foot-pounds of torque that you're putting on that sleeve is just trying to fit the sleeve to the pipe and round it that way. We don't want to do that. We won't do it. You won't get a good fit on the pipe. You end up putting a lot of pressure on the pipe, which will contribite to exploding. And we don't want... So you don't want your sleeve to have any kind of, to cause any kind of distortions to the pipe. You don't want it to have any lugs or protrusions that can possibly damage the pipe when you're torquing it down. Again, we carry a full range of sleeve sizes, so if we don't have it in, we will specifically order it to your pipe if it happens to be some kind of oddball size. For sleeve taps, we can go directly up to size on size, so 8x8, 24x24, whatever have you, but the size of the hole is dependent on the inside diameter of the pipe. So for instance, if we have an 8x8 hot tap, we are removing a 7-inch coupon, and that is a third of the structural integrity of that pipe. And we want to be tight on that pipe with a correct fitting sleeve, because you're more likely to split that pipe if you're not. So sleeve taps can be done both live and dry as well, just like saddles. If dry tapping, you don't need to have the valve on the pipe. We recently completed a bunch of dry taps locally, and even though you aren't in the trench, it can still mess with your mind, I guess, because there's no real, there's no risk to an operational system, but it can be tricky because the guys get ahead of themselves, and you can still end up splitting that pipe. So take your time, make a good cut, make a straight cut, and make sure you're lined up properly. The same spacing considerations are required, but as they are for saddle taps, 12-inch mains and under, 24-inch spacing, 14-inch mains and over, 36-inch spacing. So if there's multiple taps in the same area when you're sleeve tapping, then you should really consult the pipe manufacturer and get their blessing on it, and always get it in writing. For machine tapping, you want your cutter or the machine to be able to retain the coupon when you retract the cutter, so that's one of the biggest things for us. So as I mentioned earlier, throttle down your valves, make sure you can pop the lids, operate the valves, and ideally that would be done regularly, but like everyone, there's not enough time in the day, there's not enough people to do the work, and I know there's thousands of valves in these systems, so many haven't been operated in years. So if you're, just to put it out there, if you need help with this, you can let us know. We have a great setup with our trailer, we have a valve turning machine, and we can come exercise valves for you all day, and very little effort for us. And you don't want to have a pipe let go and find out that your valves are seized. So such a little thing can turn into a really big thing really quickly. Again, always follow manufacturer's instructions for installation, allow proper bolt torque patterns and torque values, and just use the proper sleeve slides. The big thing is gasket compression and ensuring that you have installed that sleeve correctly. So If you have proper compression, it distributes the force evenly along the pipe and ensures no leakages and lessens any risk of failure. So thrust blocking and joint restraint is something that should be used. We do not install or design that. That's when the engineering consultants in the room are for, and we will ensure that there is blocking underneath the valve so that's being supported and it's not adding any additional pressures on the pipe. So if you guys aren't connecting anything to it right away, typically it's not the case. People are usually kicking us out of the trench so they can plug in a connection. But just make sure that there's the thrust restraint is adequate for the valve's operational torque values. And of course, again, setting up the tap, you want to make sure your cutter is aligned and is lined up properly and to ensure a proper cut and reduce any stress on the pipe. So standard tapping sleeves, you can either get epoxy coated carbon steel, fully stainless steel, and again, some municipalities, they just require fully stainless steel because they have hot or corrosive soils. Or they just specifically request stainless steel. I think it's City in North Vancouver. They just want stainless on all their cast iron now. So it's either city or district. City, perfect. But yeah, so they come in both 314, 316, and if anyone's been paying attention to supply chain, it's getting harder and harder to price them because just commodity pricing's out the window. But if you can avoid it and save someone some thousands of dollars, just you stick with epoxy. Exception being on sewer, H2S will eventually eat away at all that coating. So back to our buddy here. He's standing in front of the judge. He says, "Look, Judge, I've been doing this for 25 years, probably since before you were born. And I've never had an issue." And the judge says, "That's great. Happy to hear it. Did you follow industry best practices?" And for us, if that's not already clear, that is the Unibel guidelines. So, of course, the manufacturer, pipe manufacturer, you don't have to play the video again, that's fine. And as a hierarchy would go, it's always a manufacturer guidelines first, then Unibel. They all pay Unibel to come up with the standard anyways. So basically Unibel is the Bible for all types of PVC pipe, and that's what we'll follow until otherwise told by a manufacturer in writing. So here we are today at the beautiful Marriott Hotel, downtown Vancouver, and we are surrounded by the Fairmont, the Pan Pacific, Park Hotel, the Hyatt, the Wyndham, the Shangri-La, and of course we have the Vancouver Harbor right next to us. And they all have these beautiful underground parkades full with millions of dollars of vehicles, you know, Ferraris, Lamborghinis, Mercedes, Aston Martins, Range Rovers, Bentleys, the regular Sunday grocery getter. And when things go wrong, where did I go there? So yeah, let's say he's getting ready to tap this pipe. Bobby Backhoe digs this hole for him, and maybe Henry, the hydrovac operator now, because who knows what's in the ground at this point. And Timmy, the tapper, hops in, and he has this 2-inch hot tap that he's starting to do. And what happens? Things go catastrophically wrong, as we had seen. So he runs up to his truck, he grabs a sledgehammer, he's praying he has a valve key, he starts hammering on the valve boxes, and but they're all jammed, they're all full of rocks and other crap, and he can't get the lid off. So 5 minutes later, he's still cracking away. He finally gets it open, and what does he see? It's full of dirt, it's full of rocks, it's full of concrete, it's full of needles, and all the special delights that are found in underground Vancouver utility boxes. And so hopefully he can dig down to it safely and get to that operating nut. So finally, he gets down, maybe another 5 or 10 minutes later has passed. Underground parkades are filling up with water. The insurance companies have already bought a couple of beautiful vehicles that he'll never get to drive. And so he finally gets that valve. And now he can't turn it fast. He has to turn it slow because he doesn't want to blow out the valve gate. So follow manufacturer recommendations again with that. So maybe another 5 minutes have passed, and he finally gets that valve gate closed. But as it happens, it's a looped system. So of course, he has to repeat the process all over again. And there goes another 25 minutes of his life, feels like an hour, and another couple $100,000 more in car claims. And now at this point, 4 or 5 hotels are flooding out now too. And so what's even worse is that you have the ocean right there, and treated water or sewage is flowing in. So not only do you have the hotel and vehicle insurance lawyers on your hand, you now have Environment Canada ready to pounce on you. Pay dirt. So our buddy Timmy the Tapper is in front of the judge, and the judge is going to say, well, what happened? What do you do? And naturally, Timmy's hired a good lawyer. And the lawyer is going to throw down all the specs. He's going to say, here's your Mueller, here's your Clow, TC valve specs, here's your manufacturer tapping guidelines, here's your Cambridge Brass or Smith Blair saddle installation manuals, and here's your curb stop spec. He says, look, Judge, we followed all these things, we did nothing wrong. But here's the thing. Environment Canada, the Fairmont, the Pan Pacific, the Marriott, the City of Vancouver all have better lawyers than Timmy. And the first thing one of those guys are going to do is they're going to do a quick Google search of hot tapping PVC, and they are going to find the Unibel guidelines. It's within the first 5 results, I think. And they're going to say he was too close to the bell or spigot or another appurtenance or what have you, or he was using a drill. And that's determined to be the root cause of the failure. So maybe there was a ton of tension on the pipe because Peter Pipelayer put it in 25 years ago and bent it around a boulder. But in this case, Timmy doesn't have much to stand on. So at that point, the Unibel guideline is what the judge is holding our friend accountable to, and the Bible of best industry practices. So after something like this happens, he may not ever touch a pipe again. He may be on a voluntold retirement. And Unibel pipe manufacturer recommendations always says follow specs. And if you are going to deviate, if it's because it happens, always get it in writing from the manufacturer. Get it in writing. So this picture right here, this I believe was in Abbotsford. I'm not sure the root cause of this one, but as you can see, like it's a nasty looking blowout. There's pretty sharp edges on all of that there. You know, it sucks to get hit with something like that, and it's cold water too. So like I said before, know where your exits are, and make sure you can get out, because you don't want to end up hitting your head and being unconscious in a trench. This guy right here, again, you can see it splitting all the way through. I'm, again, not sure what the root cause of this one was, but it could just be crappy pipe too. It is pretty nasty stuff. Luckily, we don't have many pictures like this. I think in the 40 years of Pacific Flow Control, there's been about maybe 6 instances where we've experienced some kind of failure. So here we have examples of what good cuts look like. With larger tabs, we always have the pilot cutter come through first, and that way that ensures we retain the full coupon when we're retracting it. And as you can see, these were both really good cuts if you compare them to the previous slides where we saw what they don't look like. So yeah, and it also, the pilot cutter also helps the full cutter make a home into the pipe, so then it's not wobbling all around your pipe, and you're just going to get nice clean cuts. You're always going to get a little bit of shavings, but for the most part, it feeds back into our machine like you can see, and we can pull it out and help clean out the system better. So here are some larger taps. As you can see, we always support the valves when we're installing them. We don't want to add additional stress to the pipe. We don't want to have any issues while we're torquing it up, and we want it to be straight and in line. So this will help us achieve good clean cuts. And this next one is again a big tap with Scotty there. We need a little bit more than wood blocking for something like this. I think we have concrete blocks under this valve. Also, the drill here is being supported while Scott is filling the cavity with water to perform a pressure test. And in the first picture, I cut Scott out, but you can see he is torquing the sleeve up a little bit, so that little gap that you see in that sleeve will be eliminated. And lastly here, this is basically what it'll look like when we leave you with your valve. Nice clean cuts, make sure the pipe's clean when we get there, or we can clean it too. But yeah, successful taps. So thank you for being here. Thank you for tuning in, tuning out, having your afternoon nap. I really appreciate it. And if you're here to get your CEUs, I know it's late in the afternoon, and I think you have one more presenter anyway, Dave from USC. So thanks again for making it through this with me. And if there's any questions, let me know.
Any questions in the room here? Yeah.
Yeah, you mentioned Unibel standards. Is Unibel a pipe manufacturer, or is it something else?
So all of the pipe manufacturers pay Unibel to come together to create this general standard. So Unibel is not a pipe manufacturer. They're just a body that will publish the standards for them.
Any other questions in here? Stephanie, we have some online. What's the max size of the tap can be made out of the main line? Is there a need to reinforce the tapped area?
Up to size on size. So if you have a 48-inch main, we can tap a 48-inch main. Yeah.
And any need to reinforce the...
It depends. If you're doing it off the side, just as long as your valve supported, no. If you're doing it off the top, then yes, there would be need to reinforce. Yeah.
Anything else? And when performing the pressure test, do you have to equate it with the mainline pressure or over the mainline pressure?
It is equated with the mainline pressure, I'm pretty sure. I have to double check on that. But.
Anybody else? Oh. Very discreetly raising your hand there.
If you're putting in a T running off the side, you don't need a thrust block in behind?
So you do. So if you're supporting the valve, you should have a thrust block off the valve, but you don't need to support the pipe anymore, I guess, if that's the question.
No, thrust block is not.
Yeah. Yeah. Yes. Your valves, you always want to have thrust blocks. Which one?
I think
we don't install thrust blocking. That is for the civil guys to do. We'll leave it like this for them. They are responsible for adding any thrust blocking.
Anyone else?
But do you have to install a thrust block, or can you just use joint restraints off the valve?
That's an engineered question.
What about HDPE pipe, water line? Could you drop
HDPE
in a
pipe?
valve?
Sorry?
Could you splice in a valve on HDPE pipe?
Like an inline valve insert?
Yes.
I don't know that there is any literature on that. I know we can do it on C900 on typical pipe, but I don't think we've done anything on HDPE yet for valve inserts.
Anyone else?
Taps, regular taps, we can do HDPE.
All right. Thank you, Nicole. You can give Nicole a round of applause.